Good morning, and thank you for joining us for the presentation Commercial Scale PV and Storage, brought to you by AEE Solar. Before we begin, if you're experiencing any technical difficulties, please notify me by typing your question in the question pane of your control panel on the right side of your screen, and go ahead and click send. We will be having a question and answer session following the presentation. You're welcome to submit your questions at any point during the webinar, and we will do our best to answer as many possible after the presentation. There will be a brief survey that pops up in a new window immediately following the webinar. If you could please take a couple of moments to complete it, I will go ahead and email you a copy of the presentation. Looks like I don't have any questions here, so we'll go ahead and introduce our presenter today, Josh Rister, AEE Solar's very own product management and technical sales manager. So, Josh, I'm going to go ahead and pass it on over to you.
All right, thanks, Caitlin. Thanks to everybody out there across the country listening in. Hope you guys are looking forward to putting the finishing touches on a great week, and looking forward to a good weekend as well. So, commercial PV and storage, an introduction. That's what we're here to talk about today. As usual, I will walk us through the agenda, what we're scheduled to cover today. Encourage you guys to submit questions in the chat function in your GoToWebinar client there. We'll cover as many of those questions as time allows. So that said, let's get kicked off. All right, I'd like to start these by just kind of baselining what we're planning on talking about today. Got a couple of disclosures down there as well I will cover. So just want to start off kind of level setting. I titled this, Are We There Yet? We'll go into applications and sectors. So where is this technology and application currently being applied? Talk about some design considerations, and I'm not going to get too far into the weeds on this, because if there's anything I've learned in the month plus of putting this presentation together, it's that if you've seen one commercial storage system, you've seen, well, one. So there's some things I can apply at a really high level that would most likely be applicable to most projects, but anything more detailed than that, we're going to need to do a kind of a sit down one-on-one session, talk about your specific project. More than happy to do that, as always. Send us an email, tech@aeesolar.com. Hit us up on the 1-800 number, and we'll get you connected with one of the guys on my team to talk in a little more detail about your project and how we can help. Last thing on the docket here, some financial considerations and disclaimers. This is really going to be where the rubber meets the road in getting paybacks and NPVs modeled out, in making the right assumptions, in making sure that this is a project that can be financed. Sometimes it's more helpful to start from that point and work backwards. I've got a lot of good links in here, some good solid data and information that helped me put this together. I'm happy to share with you. So again, at the end, fill out that survey, let us know what you thought, and we're happy to send you a PDF of this presentation with functioning links. So a couple disclosures before we go any further. Full disclosure, I am neither a tax professional, an attorney, or a tax attorney. I say that because there's some things I can convey to you about things like the ITC, things like paybacks, things like financing, but as always, your mileage will vary. I think it's a good idea to have a strong working relationship with one of those professionals who can kind of do a sanity check on your work, make sure that your proposals make sense and are somewhat accurate. And of course, you're going to want to encourage your clients as well to, have their own people that vet this kind of thing. And, as mentioned earlier, we're not going to be doing a deep dive today on technology or products. There's too much of that to go through. That's going to be a one-off. Happy to do that with you guys, in person or over the phone, kind of one-on-one on your projects. Hoping to be able to do a little bit, kind of a follow-up or part 2 to this later this year, to focus on specific storage products that we're recommending for these types of applications. So again, feel free to follow up with us in the chat function, send us an email, fill out the survey, and leave your comments, and we'd love to hear from you. So that said, we got all the housekeeping, all the admin out of the way. Let's get rolling here. So are we there yet? I think, the big question here, and we definitely see this on grid tie, on on residential storage as well. Are we there yet? Has this hit, quote unquote mainstream? Maybe yes, maybe no. So, obviously there's a ton of, front of meter and behind the meter storage being undertaken across the country. It's hard to really get a feel for how mainstream this is. So I tried to break it down by, what I would call leading indicators. So what are things that are going to indicate, that this is moving forward, that this is ramping? Things like hiring. So, every one of the energy storage companies we talk to, that provide chemical storage, that provide ESS solutions, they're looking for talent. They're looking for business development folks, for engineers. They're ramping. Typically, companies do that because they've got great expectations of markets moving forward. They're bullish on their prospects, and they want to make sure they've got the talent to serve that customer base. So, number one, hiring, great leading indicator. Financing, in all the stuff I read and all the podcasts I listen to, more and more of those ads and things are finance companies who've got capital willing to invest in, quote unquote, this doesn't apply to our sector, but I'll say shovel-ready projects. So, factor number two, check mark. Design, more and more tools out there able to help you design these projects all in one system, provide a bill of materials, provide simulations on energy, on paybacks, et cetera. So kind of check that off. And pilot projects. We're seeing more and more of these through utilities that are committing their capital to in the form of projects that they own, in the forms of projects that they're backstopping, in the form of incentives that they're providing for commercial sector storage, not just SGIP, but things across the country. So those are all leading indicators that are going to tell us kind of where this is headed. Lagging indicators. So these are things you're going to look back on and say, oh yeah, that happened. Contract sign off. Well, we're probably not seeing as many of these as we'd all like to. We're not seeing the installs. We're not yet seeing the case studies. We're seeing some of that, but not to the level that would suggest that, we've kind of crested the peak or we're at an inflection point. That's all coming. The takeaway here is all of the leading indicators indicate that this is growing. This is happening now, and we haven't yet seen the lagging indicators kind of hit the market. So, my takeaway here is, we're in the process of being mainstream on behind the meter solar plus storage for the commercial sector. One of the lagging indicators we've got access to is the installed base data from the SGIP program. Now, this is a screen cap, so it could be, depending on how you're viewing this presentation, the graphic here could be a little hard to interpret or break down, but kind of broad strokes, since its inception in 2015, 61 megawatts, not megawatt hours, but 61 megawatts of non-resi energy storage projects have been installed to date. What does non-resi mean? It means, what we would consider commercial industrial, not utility scale solar plus storage, not storage to offset spinning reserves, but behind the meter projects that have been permitted and installed and are functional under SGIP. So the biggest subsector here, and these subsectors are always a little wonky in how they're broken down. Manufacturing. Well, this is manufacturing that doesn't include transportation and warehousing. Is the biggest sector here, and we'll dig into why in a few minutes. Followed by education. So the big takeaway here on education is, that's a load profile that's just really well suited to commercial storage. So you think of your typical school or educational facility. Lights turn on at 7 or 7:30. They've got HVAC that works to make the building hospitable. It's occupied all the way through till that last bell rings, plus an hour for teachers to exit the building, and then basically the loads drop to zero. So they've got the ability to really offset some of that late afternoon usage, recharge evening, nighttime, and not see an impact to kind of quality of facility, HVAC, et cetera. really interesting takeaway here on how these projects have the interconnection agreements and the tariffs under which these projects have been applied. So two big bubbles or sectors here, or buckets, if you will. Customers with demand higher than 1 megawatt. So, think about the kind of building that's got a 1 MVA service entrance, and industrial customers with TOU. We'll talk in a few minutes as to why those two are being applied, but really kind of fits what we're going to talk about applications. It wouldn't be a presentation on solar plus storage if we didn't reference the duck curve. So this is information from Cal ISO. Again, we're a little California centric here, but so far it's been, besides Hawaii, which is, I guess, even more of a special case. It's the best information we've got access to across, a pretty high base load. So we're seeing a more and more pronounced duck curve the farther along we get into the evolution of these projects. So really speaks to the impact that somebody like ISO or other RTOs are going to have to address, and really the opportunity there if you've got a load curve that doesn't completely align with this. If you've got the ability to shed load in the evening, that's going to be more and more attractive for utilities. They're going to be offering more and more attractive tariffs and incentives to do so. So my favorite part of these presentations, what are the applications we're really targeting? How do we break this down by, what's the job to be done? Or is, guys on my team will tell you on the phone, what are you trying to do? So the three kind of main buckets that I've got here, and obviously on any of these projects, there's going to be some overlap. We'll speak to we'll speak to benefit stacking or value stacking in terms of, you're probably not going to design a pure play project that only targets one of these applications. Most of these, if done well, are going to be able to provide, it's a lot of jargon, but be able to provide multiple revenue streams. So, some value derived from load shifting, some value derived from demand charge management. Some of these projects are going to have, Hansel and Gretel breadcrumbs to a demand response program. They're not pure play, but if we throw that out the window for a second and just consider pure play applications, what are they? Load shifting. So at its base, you're taking load off the grid during a certain window of the day, and you're reapplying it later in the day. And what we mean by load shifting is kind of whole scale. You're taking large swaths of load, you're doing it at maybe not a circuit by circuit level, but by sub panels, or really just offsetting as much of that metered meter read power as possible. So you're doing this at a high level, and you're not doing this to shade peaks, but you're really trying to move big blocks of not power but energy from one period to another. So obviously when we're talking about that, we're talking about trying to mitigate some TOU, time of use peak or off peak effect. I'll say it requires some interesting tariffs and load curves. And this is going to be, in terms of storage, in terms of watt hours, the most intensive application. Next kind of bucket here, demand response, or ESCO, energy service company. In theory, this is offering, aggregated demand response, load shedding, frequency response as a service. So, probably not a play for the types of folks we've got on the phone who are, small, medium, or even large, residential / commercial, or just commercial installers. This is going to be for folks like Enernoc, who have national footprints, who really deal in the financial sector of energy more than the kind of nuts and bolts. They're interested in aggregating lots and lots of buildings, providing demand response events that people can opt in and out of, and then providing kind of, micro revenue streams for that. So I'd say unclear business models, not because they haven't been proven out, but because to a certain extent, those are black boxes. that a lot of us aren't going to have access to. The last one, and I think perhaps the most interesting one for our discussion here today, is demand charge management. So it's got the highest payback to date. It's been, I guess, the most heavily subscribed application because for a lot of folks, it's the most impactful. It can be, in my opinion, the most challenging to sell. Unless you're dealing with a certified energy manager or somebody with, a combination of buildings, facilities, and energy in their title. These are going to be things you're going to have to coach people on first. What's the pain? You're really going to have to break down energy bills. You're going to have to do a lot of, site auditing. But if you can put together the right proposal, you can address the right loads, it can be some really impactful savings for your customer. And interestingly enough, this is something that's really stood in the way in my opinion, higher penetration of commercial grid-tie storage. And the point there being, we've quoted and designed a ton of commercial rooftop systems, and installers have gotten to the point where customers interested, they've taken the proposal back to the their tax professional, and their tax professional says, hey, this is great. You're going to save, megawatt hours a year, and here's what that savings amounts to. However, looking at your bill for 30 seconds, half your bill is demand charges, and this may or may not solve that issue. If you don't know when during the day your demand charges are occurring, a possible really bad outcome would be you install a great, shiny rooftop grid-tied solar system, and you really don't address the demand pain, and the savings are not what you've estimated, and you've got some really unhappy customers. So now that we're able to address this in a more functional, more practical way, I think this is really going to lead to greater adoption of solar overall, which may seem counterintuitive given the cost of storage, but I think it's going to bear itself out over the coming years. So that was a little bit longer than I intended to cover on this slide. Let's keep moving along. Let's do a little deep dive here into demand charge management. So hopefully this is a review for most of the people on the phone, but what's a demand charge? Well, commercial bills, almost, I won't say predominantly, but increasingly are composed of two different charges or sets of charges. So an energy charge, and that's a dollar or cent, hopefully a cent rate per kilowatt hour, and it bills may be a combination of TOU or peak off peak, but basically at its essence, you use this much energy, here's your rate, ipso facto, here's your energy charge. They're doing this based on, well, we had to buy fuel, or, we had to run a generation to provide that energy, therefore here's your bill. Then there's a demand charge, which is I'll say a fixed charge assessed on a peak or maximum kW number per period. So we'll address this in the following slide, but basically here was your peak number that we saw hit the meter during this monthly interval. We're assessing you 15 or 20 or 25 or 40, we've seen on some bills, dollars per kW, and you pay it based on the whole month. You may have only hit that peak once during the month. That peak may be twice the other next highest kW value. Doesn't matter. Utilities assessing you for, in their words, the infrastructure associated with providing that peak amount of energy. So I've heard some folks refer to this phenomenon as the United States is building out an electrical grid that's the equivalent of a 100-lane freeway because they want to be able to address traffic on the Wednesday of Thanksgiving, and the other 8,680 hours of the year, it's completely overkill and it's not needed. So that's the rationale behind demand charges. They're painful. I think they seek to address a need that will not be a need in the future given the ramp of storage and specifically behind the meter storage, but it's what we've got to overcome for the moment. And it's really driving a big increase in this application around what I call demand charge management. So a couple graphs here that may be interesting for you guys to check out once you receive the slides. There's a paper that I linked to here from NREL on demand charge management and kind of what the opportunity is. When they ran some numbers, they figured out that, at the time this paper was written, I think it's 2016, kind of the break-even point where it started to become interesting was a demand charge of $15 per kW. And you see there kind of the number of customers who have tariffs that meet that threshold. And then down below, states with the highest demand charges. So, most of you guys are familiar with your local tariffs and, local billing practices. You're probably aware of, if you're in this market or not. Interesting to see how prevalent this is becoming in places around the country that, you wouldn't necessarily consider as, solar or storage hotbeds. I think about some places in Minnesota, some places in, Nebraska that, wow, could be a good fit for this. Not necessarily solar hotbeds, but, soon to be very strong storage hotbeds. So demand charges, kind of visually, what are we talking about? A great graph here that I'm happy to share with you guys. So two theoretical customers, Company A, who hits 100 kW basically the entire period, and you see there their energy usage, 72 megawatt hours in this period, a $7,200 energy charge. They're paying a demand charge of $8 per kW, 100 kW met, every interval of that period, $800 demand charge. On the other hand, you see Company B, who, from the looks of their billing, has done a lot of energy efficiency, perhaps has solar, but they've got one period in the month where, worst case scenario, it looks like all the loads happen to turn on and run at once. Other than that, they were a very conservative customer. You see here, for somebody like this, your traditional net metered solar system is going to do a lot to address their energy usage, but it's going to do nothing to address their demand charges. So Company A, again, the transmission distribution planner's dream: high energy is high revenue, a consistent peak, easy resource planning, and oh, by the way, they're getting a big demand charge from this customer as well. Company B, somebody we would consider in the solar industry to be doing all the right things in terms of, minimizing their energy profile, still getting hit with their demand charge, and depending when that period was during the day, PV may or may not address that impact on its own. So some design considerations for demand charge management. How do you go about even, building out a bill of materials or designing a system? Really, it's going to start with meter. And, just looking at a customer's utility bill is only going to give you half the story. It's going to tell you, that bill is going to tell you at a high level, what proportion of their savings could be addressed by demand charge management. But it's not going to tell you, it's not going to tell you which load is driving that peak kW number. It's not going to tell you at what time of the day. For that, you're going to have to get, meter level data, which, can be provided from a lot of the, forward-thinking utilities out there. But you're going to need to get down to the, sub-panel and sometimes circuit level to figure out if this is something you can address. The design and the paybacks of these projects is 100% contingent on identifying the problem loads. So what's a problem load, real quickly? This is something that's driving a big kW number that is possibly repeatable, possibly not. But what the peak kW number you're trying to address. And for this to be the most cost effective, it's a peak load that has a, let's call it a low energy function. So a real high ratio of peak to kind of normal draw. Think about, motors turning on, compressors. It's not going to be lighting. It's not going to be things like fans that have kind of long duration energy curves. So do the easy work first. I cringe a little bit being in the solar distribution and storage distribution world, but there's a lot of things that can be done for your customers that have nothing to do with storage or PV. Things as simple as load scheduling during non-coincident periods can be huge. If you go out, you're metering things and you're noticing that, they've got pumps and things that run while all of these other loads are occurring that, perhaps could be rescheduled. Perhaps you can work with the production manager and stagger when these machines are turning on for the first time every day. Schedule loads, some of these during PV production times if possible. Consider a load controller to desynchronize loads. We're seeing residential customers out there using, small load controllers to address resi demand charges. Absolutely, the same technology exists out there in the market and has proven paybacks. So I would say I would classify all of that as the easy work first. Scheduling is only going to get you so far, and a lot of these things simply can't be rescheduled. If you've got a production or manufacturing facility, you can't tell them, run the mill from 8 to 10 and then run the finishing machines from 4 to 5. Production doesn't work that way. A lot of these things need to be run at the same time sequentially. You've only got so many shifts during the day you can run these things. So some of that can't be done. That gets us into kind of doing the cool stuff. So, islanding, I'll call it, peaky loads behind a storage system. We've worked with some customers and we've recommended that certain pumps, motors, et cetera, be put behind a storage system so that we're basically chopping the peak off of that load when it turns on. And it's perhaps best identified or exemplified by this graph down here at the bottom. Basically what we're doing is we're using energy storage like a reservoir to draw from and bring down the peak on those loads. Think about it as, kind of as a capacitor, really. You're letting those loads draw from storage first, while they're turning on, while they're rotating mass, when the highest peak is occurring. Once they get kind of to a steady state, then they're going to, your contactors and things, your circuits are going to close. Then you're drawing power back from the grid again, and your storage can recharge. So it can be done by circuit level, across the facility. It's really going to depend on the facility, how the facility was wired, and what those peak loads are. And again, happy to dive into this in excruciating detail if needed, to help you fit the right solution. Keep moving here. Load shifting. So load shifting works best, deep dive here. Load shifting works best in time of use areas with high differentials between peak and off peak. Think of this as energy arbitrage. So the math of the three applications, and the ESCO one is the one we won't cover here, but the math on load shifting is the most straightforward. This is, kind of assuming that you're not going to address the demand charge function. But basically, I know what my energy, my rate is during my peak window. I know what it is during my off peak window. I've identified a block of loads that I can shift from peak to off peak. And I'm going to compare my LCOE, my levelized cost of energy for storage. Compare that to my delta between peak and off peak. So I said at the beginning when we kind of did our application overview, kind of for this to make sense requires some maybe creative or interesting tariffs. Basically what you're going to need here is some pretty aggressive deltas between peak and off peak. Potentially cost effective with a delta as low as 25 kW is some of what I found in my research. Unfortunately, in places like California, the changes to TOU schedules may put this at risk. So one that was approved here recently was an IOU. I believe this was SoCal Edison, but it could have been SDG&E. Proposal to shift that peak window from 11 to 6. When a lot of these loads could be offset just directly with PV to 4 to 9. So now, if you're doing this under storage, you've just becomes a little trickier, obviously more difficult to address with PV only. And the quote here from GTM, customers that export most of their solar during the day and then have a higher evening load will suffer. If you are trying to do energy arbitrage here and do some load shifting where you're moving load from peak to off peak, potentially you've got another 3 hours you've got to wait to get into that off peak. So your needs are potentially higher. You've got to reserve some of that production, more of that production every day to storage, getting your loads, out of that window. And the pain here is twofold. So cheaper tariff for exported power, and the later peak again, that makes the shift longer in duration. So more energy you're having to carry. But there's a lot of product out here that addresses this. If you are, dealing with a customer that perhaps doesn't have those peaky loads, perhaps doesn't have a high amount of their bill going to energy charges, this could be a great fit. Again, this is a customer that you're going to want to try to address with, things like scheduling first. Maybe there's things that, they can just very easily put on schedulers and timers and things to push them out of that peak window. Always best to try to address that first, can be a lot more cost effective. I know we're all in the business of selling solar and selling storage, but if you can put together a holistic package like this for your customer, they're going to be a lot happier in the long run. At this point, we're going to get into a little bit of the financial considerations when undertaking one of these projects. So there's a great podcast I'm going to link to from the folks at Green Tech Media. Apologies, I don't remember off the top of my head if it was Energy Gang or if it was The Interchange, but great podcast. It's in the links here. Number one biggest hurdle is, and this applies to solar, this applies to storage, this applies to energy efficiency, you name it. In most cases, your most impacted stakeholder, so the one who pays the energy bills, is not the decision maker on if a project like that is going to be allowed under the lease agreement. So, tenant pays the energy bills, but the landlord owes the building. Landlord may or may not be interested in, putting a lien or using the building as collateral for a loan for that system. So a PPA can be viable, but the alignment of the PPA length to the lease length can be problematic. Generally speaking, tenants lease property because they don't want the long-term liability of being in a building and owning it outright. So I think it's uncommon that you're going to see leases of the length of the payback or the lifespan of a PV system. We're looking at systems now with lifespans of 20, 25 years. I challenge you to find me a lot of customers that have leases of that length. And the specific instance they addressed in this podcast was a guy in the Bay Area who, trying to do the right thing by his company, by the environment, saying, hey, we should do solar on this building. We've got a 9-year lease. And just trying to make the incentives align between the stakeholders of the tenants, the occupants, and obviously the building owner. So direct purchase is viable if an owner is willing. If you can convince your owner to do this because it's an office space and he can market that solar as a value add or a savings to his clients. If he's interested in locking in that ITC credit, that can be great. But again, the building owner is putting that on his own balance sheet. He's holding the property for 5+ years. This was a term that I was not aware of at the time, ITC clawback. So you undertake a project and you take that ITC credit and you sell the building within 5 years. You then owe back to, I believe, the Treasury Department, a prorated amount of that ITC. So, can make things a little tricky if you're dealing with a property owner who's got a shorter, kind of timeline on that building. Without a doubt, these hurdles are going to be most likely the highest hurdles you're going to face in these projects. It's not going to be around the design. It's most likely not going to be on the cost or payback. It's going to be, how do we get this thing paid for? How do we get the people with, the capital aligned with the people who want to see the savings? The bright side here is there's more and more companies and sources of capital for these projects who can offer a variety of financing of PPAs, of loan products, of leases. And, we see the cost of solar coming down, being more competitive. It's more and more feasible to undertake these as, as cash projects. Some specific finance considerations around demand charge management. So this is going to sound like a recurring theme. The solution and its payback are entirely contingent on finding and affecting a solution on the quote unquote right loads. So if the peakiest loads are not selected, or you're addressing loads that are not necessarily the ones driving those peaks, then you're going to have a bad time. And what I mean by that, if you're not selecting those peak loads and you're not addressing them, those loads are still going to hit the meter. You're still going to be driving a peak demand charge, and you're going to have to, hopefully best case, go out and rewire some things. Worst case is you size the system improperly, and you're going to have to go back and hopefully secure a change order and redesign the system. So again, takeaway here: meter, meter, meter. Make sure that you're finding the right loads. That the ones you're addressing are ones that will drive peak demand savings and do so cost effectively. Internal rates of return on these projects can be high, approaching 20%. So you look at this number, and on its face, hey, this is great. These projects can save, have a rate of return of 20%. The flip side of this coin is that projects with low rates of return aren't happening. So there's a hurdle here where a project's got to hit a rate of return of 20% to be considered interesting. And there's some risk associated with these projects that you're financing your capital sources, may not put the same amount of confidence in your model that you do, or even that your customer does. And if they don't, they're going to discount those rates, and they're going to require 20% hurdle rates for these projects. So some great quotes here. Today, demand charge management is the major avenue through which these storage projects are making their economic case. But this alone is not enough to pencil out in most U.S. geographies. So that's what we spoke to around, value stacking. You're going to have to position this project, this proposal, as, yes, absolutely demand charge management. Here's what I can save you on that demand charge. By the way, there's net metering involved, and that's going to save you X. There's an ITC, and that's going to get you Y. You've got a path down the road to monetize frequency response or volt var, and that could be Z. You're going to have to kind of stack all these things along with, it's solar after all, so you're going to have to package the feel good part of it as well. Try to tie in perhaps the attractiveness to talent that might be associated with a project like this. Lots of different things you're going to stack here for this to, make it past that 20% hurdle rate. Another quote here: limited revenue streams currently available. Demand charge management is easy to model and communicate to lenders, but in many cases it needs to be paired with other value streams. So just kind of reiterating that point there around value stacking. Let's talk briefly on design considerations. Again, not getting into the real nitty gritty of which products you're going to specify and how do you calculate voltage and all those great things that we love to talk about in our day-to-day. Metering. So I think the best way to get into this, have a great E-Gauge package. Is the company we work with that can specify a really reasonable, in my opinion, system for metering mains and branch circuits. Think of this as an investment in a tool. This is not a line item on a project that you're going to purchase and have to amortize into a single project. This is a tool that you're going to use to make proposals, hopefully over and over and over again. Think about it as the next step in your fluke meter. So these are great packages, and we can definitely help specify one for you that are going to be able to tie meter level data, branch level data, load level data, and really figure out what are the loads that are driving those peaks. Tools like Energy Toolbase that can help you model, this system, but also model out different savings. You can also model out a system with a couple different tariff options. So that's something we haven't really addressed in this webinar today, but you know, part and parcel of these projects is making sure that we can get a customer into the best tariff after interconnection for that system. Tariffs on their face, oh, they're simple. It's, you know, this during this window, this during this window. Can get really complicated though when you're thinking about interactions between different systems and comparing, you know, 1 or 2 or 3 tariffs. Having walked through Energy Toolbase, it's amazing the amount of different tariffs that are available, you know, even in a given utility district that customers could apply. I'll say location matters, just real high level. You got to do a little bit more thinking about where you're siting, where you're locating the inverters, and obviously the energy storage and the impacts that'll have, you know, temperature-wise, voltage and cabling-wise. Again, you know, this goes back to, you know, metering, doing a brief site audit, you know, kind of figuring out what you have to work with on these projects. Power factor. So, you know, not something we typically deal with in residential energy storage. I think for the most part, you know, we're dealing with unity or close to it. We talked about manufacturing being the #1 sector that these demand charge applications are being applied to. Incidentally, that's the sector with on average, the worst power factor quality. So that's something you're going to have to take into account. You know, what's the power factor I'm seeing at the meter? What's my impact there going to be on the efficiency of my solar and my storage? Am I going to be able to inject at a different power factor? You know, maybe there's some value derived there from the storage you're applying as well, that you're going to be able to clean up the power on some of these loads. Should have put in my disclaimer, I am not a power systems engineer. I know very little about power factor besides the fact that it's hard to explain to laymen, and it can be incredibly impactful if you've got bad power quality. And then here's some typical concerns of you know, building code, rapid shutdown, racking, lots of changes every year, and we're looking at a big one coming up in 2018. So we're getting to that point where we're going to have to take that milestone into account, because the, excuse me, I said 2018 and I meant 2019. January 1st, 2019, in a lot of areas, there's an addendum. There's a TIA that's being applied to NEC 2017, which will require module level rapid shutdown. In years past, those requirements have been geared with a timeline of interconnection or plan approval. For 2019, it will be installation. So, you know, even if you're grandfathered in with an interconnection agreement that had previously been granted, or, you know, stamped plans, if you're installing January 1st or later, you're going to have to be compliant with that new standard. And then, of course, ITC qualifiers on energy storage. Would have put this on the previous slide, but ran out of room. Basically, what we mean there is you're going to have to prove, or at least provide some calculation on how that battery is being charged. And there's a D-rate function here on the amount of tax credit that can be applied. If you're, the example here from Energy Sage, if you're charging the battery with solar or renewables 80% of the time, you get 80% of the prorated tax credit for the battery. If you're doing it less than that, you're getting less tax credit. So something you're going to have to take into account. How do I size the storage so that I can recharge it, you know, every day, possibly multiple times if it's loads that are cycling multiple times a day. Definitely make sure you're taking that into account. Again, consult your tax professional on how much of that you can put in the PV part of the system and how much of that cost you could put in the storage part of the system. At this point, I want to flip through a couple tools that we recommend for sizing these kinds of things. Homer Pro is going to be much more around, you know, kind of microgrids. Energy Toolbase is going to be much more geared towards grid interactivity. Great tools that will help you model all of these things in excruciating detail, and heavily recommend both of them. This slide I've got is just resources. So that great podcast I mentioned from GTM, good paper from Enernoc on explaining and understanding peak demand charges. This next one from Vox Media is pretty elementary, but, you know, could be good priming material for your customers. some good information on how TOU will affect commercial solar from GTM. Demand charges explained in a webinar by NREL, so this is going to be a little more wonky. Good information here from Aurora Solar on quantifying the value of a solar installation and kind of that value stacking that we talked about. And this last one, taking a more financial angle on promoting solar on leased buildings. Lots of great info here. I'm probably only touching the tip of the iceberg, but would recommend reading through these things. I think a lot of the stuff I share with you guys is going to be things that are going to help you fall asleep on Monday night. These will be interesting, suffice it to say. At this point, we've got time for questions. So, Caitlin, I'll kick it over to you. I imagine there's a few that have popped up, and hopefully I'll be able to answer them.
All right. So thank you, Josh. So we'll go ahead and start off the question and answer session now. If you do have a question, go ahead and submit it through the question pane located on your control panel. And again, we'll try to answer as many questions as possible. You can exit the webinar at any time during or following the question and answer session. The survey will pop up in a new window once the webinar ends. If you could please go ahead and give us your feedback on the survey, and